So we are going to start with the subtopic the plane under analytic geometry. First we will discuss some basic concepts and formulas and then take up the questions. So to begin, the definition of the plane. A plane is a surface such that all the points of a straight line joining any 2 points on the surface lie on it. So I'll just draw a plane. So this is a plane. If you take any two points on the surface of the plane and connect the 2 points with a line, all the points on the line should lie on the surface. Only then we can say the surface is a plane. So I will just show you an example where it is not a plane. Let's take a curved surface, something like this, something like curved. Okay. So this is a curved surface, something a bent sheet. It's like a bent sheet. I hope you understood. So let's take these 2 points. And if we draw a line connecting these 2 points, as you can see, all the points on this line is not in the surface. So this surface is not a plane. If you take any 2 points and draw a line, all that points on the line should lie in that surface for that surface to be plane. And let's take another figure which looks something like this in two-dimensional space, something like this, a curve like surface. So if you take this point, any 2 point like these 2 points and draw a line connecting these 2 points, as you can see, these points lie outside the surface, and hence this surface, even though it is in one dimensional, the surface lies entirely in one dimensional space, and it's a plane. If you consider this plane, this surface lies entirely in this plane, but still this surface is not a plane, since we can take 2 points and connect 2 lines and then see whether all those points lie in that surface. So this is the definition of the plane. You can use this definition to show different equations, to show whether different equations are plane or not. Yeah, okay. So moving on, the equation of the plane in normal form. So equation of the plane in normal form is Lx plus My plus Nz equal to P, where L, M and N are direction cosines of the normal to the plane. So this is the figure. Let's say this is the plane. This is a plane, a random plane. P be any point on that surface, and we have the normal to the plane as N, where N is a unit vector. So if this is the case, the direction cosines of this normal will be L, M and N. And if the direction cosines of the normal to the plane is L, M, N, and P is the distance from origin to the plane. So to find the distance from origin to the plane, we drop a perpendicular from origin to this plane, and ON be that perpendicular. The length of ON be P. So if we have the direction cosines of the normal to the plane and the distance from origin to the plane, we can construct the normal form as Lx plus My plus Nz equal to P. So its proof is pretty simple if we use the vector concepts from vector. So we have ON as Pn. P is the magnitude of ON and N is the direction of that normal, and N is a unit vector. So magnitude of ON is P, and P be any point on the plane X, Y, Z. So X, Y, Z be any point on this surface. So we have OP equal to Xi plus Yj plus Zk, and On is Pn, and which is nothing but P into Li plus Mj plus Nk. So since direction cosines of the normal is Lmn, a unit vector along that direction cosine will be Li plus Mj plus Nk. So P into Li plus Mj plus Nk will give On vector. So otherwise Pli plus Pmj plus Pnk. Now NP, what is this NP vector? NP is nothing but OP minus on. I'll just show this np vector. What is np? np is nothing but this vector. If you take this no plus op, or no can be written as op minus on. So this is what np vector is. So np vector is op minus on. So op minus on is this x minus pli, y minus pmj, z minus pnk. Now we know that this np vector and n vector is perpendicular. Any n is a normal vector to the plane, so any n will be perpendicular to any vector lying in this plane. So np dot n will be 0. So using that, if you see, we will get this equation: lx plus my plus nz is equal to p. And here we are using l square plus m square plus n square is equal to 1. So this equation is the normal form. So any x, y, z satisfies this normal form equation. So we remember we initially took p as any point on the plane x, y, z. So any point will satisfy this equation, and this is the normal form: lx plus my plus nz equal to p. So this is the equation of the plane in the normal form. And now let's look at the general form of the plane. General equation of the plane will be of this form: ax plus by plus cz plus d equal to 0. So here we have 4 variables. As you can see, it is very similar to the normal form. In the normal form we had lx plus my plus nz equal to p. So to convert this to normal form, we just move d to this side. So we will get ax plus by plus cz equal to minus d. Now divide throughout with root of a square plus b square plus c square. So we will get a by root of a square plus b square plus c square, x plus by root of a square plus b square plus c square, y plus c by root of a square plus b square plus c square, z equal to minus d by root of a square plus b plus c square. So now this is L, this is M, and this is N. This is L, this is M, and this is N, and this is P. So we can convert easily the general equation of a plane into normal form. And as you can see, whenever we are given an equation like this, A, B, C will be the direction ratios of the normal. So from here, you can see that A, B, C are direction ratios of the normal. And we can, if you want to find the direction cosines of the normal, we can just simply divide it with A, B, C with root of a square plus b square c square plus c square, and we can find the direction cosines. So anyway, this is the general equation of a plane. Now we have another form which we call intercept form. This is when we have a plane like this, and so it is intercepting each axis. So sorry, that's not correct. So it is like this. Let me just draw it a little bit neat. Oh, there is not enough space. Okay, okay. I will just draw it with another color. Then it will be more clear, I hope. Okay, this is the plane. Let this triangle. It is this plane is extending in each direction, but just it is making an intercept A with x-axis. This is x-axis. This is y-axis, and this is z-axis. So it is making an intercept A with x-axis and B with y-axis and C with z-axis. So this is the intercept form. If we know these intercepts A, B, C, we can construct the intercept form of the plane, which will be x by A plus y by B plus z by C equal to 1. So we can either proceed from a general equation of a plane or even the normal form to arrive at this intercept form equation. So I will leave you to derive this intercept form equation. If you find it difficult, do comment under the video. So plane through a given point x1, y1, z1 and perpendicular to a given line whose direction ratios are ABC is another form. So we are given a point in the plane and perpendicular to the given line whose direction ratios are ABC. So we have a plane and we are given a point x1, y1, z1 and we are given that normal direction ratios of the normal is ABC. ABC is the direction ratios. If we are given this much information, we can construct the equation of the plane as A into x minus x1 plus B into y minus y1 plus C into z minus z1 equal to 0. So this is another form. This is another form. Next, let's see the general equation of the plane passing through 3 points. So to define a plane, we just need 3 points. So if we are given 3 points, x1, y1, z1, x2, y2, z2 and x3, y3, z3, we can construct the equation of the plane that pass through all these 3 points. So easier method would be, since say this is the plane we are looking for and we are given 3 points. Let this be x1, y1, z1 and let this be x2, y2, z2 and this be x3, y3, z3. So we are given 3 points. So now easier method will be just find a direction ratios of the normal. So for that, we know we can use the fact that any normal like this n will be perpendicular to the direction ratios of the line segment joining any 2 point given. So we can randomly pick 2 points, draw a line and see what is the direction ratios of that line. The equation to find the direction ratios of a line joining 2 points was discussed earlier. So we can just find the direction cosines or direction ratios and we know the fact that n and the direction ratios will be perpendicular and we use that fact to find the direction ratios. Once we find out the direction ratios of the normal as A, B, C, we can use this equation A into x minus x1 plus B into y minus y1 plus C into z minus z1 is equal to 0. So that equation will lead to the formula A into x minus x3, y3 and z3 is the point left. So A into x minus x3 plus B into y minus y3 plus C into z minus z3 is equal to 0 will be the required equation. So this is one easier, while solving the problems in the exam hall, this will be the easier method. And there is an alternate method you can use, a general method you can use, which will be to start from the general equation of the plane. So let general equation of the plane be ax plus by plus ez plus d equal to 0. So that will be the first equation. Now we can apply all the points to that general equation. We will get ax1 plus by1 plus cz1 plus d equal to 0, ax2 plus by2 plus cz2 plus d equal to 0, ax3 plus by3 plus cz3 plus d equal to 0. This will be our equation 2, 3 and 4. Now we just have to eliminate a, b, c and d from all these 4 equations. So which will give, if you solve, you can use this matrix method and once you solve, you will get this as the equation. This is determinant of x, y, z1, x1, y1, z1, x2, y2, z2, 1, x3, y3, z3, 1 equal to 0. So determinant of this 4 into 4 matrix will give the required equation. So as you can see, while solving the problems, finding this determinant of 4 into 4 matrix will take some steps, long steps. So you could choose this easier method to solve to get the required equation. So you can use either method. You will ultimately get this as the same equation as same equation for the plane. So since we already discussed this equation and found out the equation of a plane satisfying passing through these 3 points will be this, we can use this idea to discuss another concept, which is the condition for 4 points to be coplanar. So for that 4 points to be coplanar, that fourth point should satisfy this xy z1, this equation, right? So we'll just plug in that x1 y1 z1 or the fourth point to this equation, and we'll get this as the condition for 4 points to be coplanar. So x1 y1 z1 1, x2 y2 z2 1, x3 y3 z3 1, x4 y4 z4 1. So this determinant has to be 0 for the 4 points to be coplanar. So this is the equation. So these are the basic concepts that I wanted to discuss before starting the problems. So yeah, I'll just go through this once more. Just yeah, okay. So from next video onwards, we'll be solving problems from the plane. Do comment if there is any doubt. Thanks for watching.